experiment we are carrying out now is food test. It is well known that food tests are very common experiments that are often asked in the exam. But most candidates still go astray because they don't follow the procedure well and they do not report it properly. So we are going to carry out an experiment of food test using one solution which we are going to prepare. But candidates should take note that at times a solution is given and they are just asked a vague question to determine the contents of solution A or B. So they are not limited to either testing that solution only for starch or testing it for glucose or testing it for proteins or whatever. They should carry out the test of all the classes of food before they will determine what that particular food substance contains. So we have one solution here that we are going to prepare. I will tell the name of the solution. This is corn flour. So what we are doing is we'll dissolve it in water. We dissolve the corn, we put it in our beaker. Then we add water. This is pure water. We add water. When we add water, we stir it. We stir it so that we have a homogeneous solution. So we stir it. This is our solution that we have prepared. But candidates will know that in an exam, the solutions are not named. They just have solution A. So this is to tell them that these solutions that they see are very common things that are with them. They can be something strange, but we are the ones who prepare the solution, and they are not different from this one that I'm preparing. So if I prepare this one now and come and put, and I write it solution A, and then I ask you to test for the contents of solution A, you will not know what is there. You cannot know whether it is whatever. There are many things that can be white. You will not know what is there. But I, the examiner, I know that it is corn flour. So we are going to carry out the fourth test. The procedure is, we are going to follow it as such. He will test for starch, for the presence of starch in solution A here, using iodine solution. Then I will carry out the test for fats in solution A using the test of fats using filter paper, and I will also use the Sudan 3 solution. Then he will carry out the test for a simple sugar using solution B, and he will use Benedict's solution. Then the third person, he will carry out the test for proteins using still the same solution B, and he will be using the Mellon's reagent. So we are going now to see how we are going to carry out the various tests. So each of us is going to get 1 cm cube of the solution. This one now is a procedure. So the procedure is that you measure 1 cm cube of the solution. So you measure your 1 cm cube. But I take note that before measuring it, I stir it up so that the solution is well mixed. Yes. And measure it. You measure the 1 cm cube. So I also draw the solution. When I draw it, I see that it's much. I turn it up so that the air bubble goes above on my syringe. Then I push it. I push it. And when it starts coming, I can now turn it onto the solution and make sure that at the end, I have only 1 cm cube. So I have 1 cm cube. So reduce it on to have 1 cm cube. Okay. So after having the 1 cm cube, you use a Pyrex test tube. Pyrex test tubes are advantageous because they are resistant to heat. When you heat it even directly, it will not crack. But you can heat it in boiling water or in a water bath. So we now put our solution right into our test tubes, and then we hold it with a test tube holder. When you put it, you then hold it with your test tube holder, so it is not touching your hand. Then, what you do now is, you now go to your reagent. You now go to your reagent, and for starch, you will only take a bit of it using a dropper, and in my own case, using Sudan 3 solution, I will only take a bit of it using the spatula, and I will take powder of the small powder, and I will drop it, and we'll see what will happen. Then on his own case, using Benedict's solution, he will take an equal amount that he had taken. So he'll take an equal amount, and for Mellon's reagent, he will also take an equal amount, or he can take less, but not more. So I take, yes, 1 cm cube. Just take any quantity, just draw it up. Yes. And then you add it to it. So when you add, you shake and tell us your observation. Shake and observe and tell us what you have observed. So I add a bit of Sudan 3, and then I shake. Yes. So what have you observed? Tell us what you have observed.
I've observed a blue-black correlation. So the white, solution turned blue-black.
But what is the intensity? So when I look at it, I see that the intensity of the blue-black correlation is very, very mild. So this implies that this food substance contains very little starch. You can see particles of blue-black in this solution. But if the starch were so much in it, it will be very, very dark blue. So it is very much, the blue-black correlation is very, very mild. So this implies that this solution contains very, very little starch. So alternatively, another test that you could carry out is to put the solution on a white tile and then you drop the iodine solution. So you do it. Then, in my own case, when I added the Sudan 3 solution, I've observed a brown coloration, and there is also distinctly red precipitate inside this solution. There are distinctly red precipitates which are sparingly distributed inside this my result. So this automatically means that this food substance contains fat, but the fat too is not very much. There is some fat, but it is not very much. That's why I can observe these sparingly distributed red precipitates. Then in your case, what have you observed?
The white solution was turned into greenish coloration.
Okay, this is the first observation. It has turned greenish when you shake it. Okay, that's it. Then what have you observed? You cannot speak louder. So here, from just adding the Mellon's reagent, you already observe some brown precipitates settling down. But you first of all see a cloudy suspension, which is up here. This is cloudy, it looks like clouds.
Yes,
so on addition of Mellon's reagent, a cloudy suspension is observed, and then on settling after some time, some brownish precipitates are found under. Okay. Observe that there is a coloration here, and then he has also carried out a second test on starch using dropping the solution on the tile and dropped the iodine solution. And since the tile is white, you can now see the distribution of the blue-black coloration. So this implies that this solution contains starch. So this is just all about the test for starch. And then in my own case, you see that with time, the brown color is now well distributed. So this is just implying that after 5 minutes, when I'm observing without heating, there's a brown color and the precipitate now has increased. I can see the precipitate on here, which is very, very distinctly red. So what I will give from here as a conclusion is that the solution A, which is here that we are given, contains fat. Then for this one, you have to proceed to heating. So you go to the heating source and you heat it. What will obtain their final result. No problem. Maybe your own is correct. Take it. Take it, all right. So we have seen that on heating, this is the test because we are testing for simple sugar, that's glucose, using the Benedict solution. So on heating, for about 5 minutes, we see a brick red precipitate which is settling down here. We can see the red color. So this is the brick red precipitate that has settled down here. And the concentration is also not all that very good, but it is there. So this one implies that this particular solution, this particular food substance, contains glucose. And that is why we have this brick red precipitate down there. Then, on the test for protons using Mellon's reagent, you see that the color is very, very distinct. You see that there is a clot. If I try to give it like that, there is some clotting which is settling down there, and you see that the red to brown precipitate is very, very distinct. So this implies that this solution contains a lot of protons. And we have prepared the solution together, and this was corn flour. So this simply means that solution B, which is corn flour, contains starch, it contains fat, it contains glucose, and it contains contains proteins. So if you know what each food item contains like this, it can help you. It can even help you to determine who should consume that food and at what level. Like for example, any food which contains proteins is good for pregnant mothers, is good for growing children, sick persons, and all the like. And the food that contains so much starch is not good for little babies and all of those. So knowing the contents of each food particle or food substance before consuming it is very good because it helps us in our health and it also helps us to modify our lifestyles. So the next item now is we have carried out these experiments and we have observed throughout and we have had now our results. Then how do we report it? So in reporting, which is the most important part, because the examiners will only mark what the students have written. They will not mark what they did. So if a candidate does something like we are doing it right here and you don't write it down, then it means that you will not have any mark because you cannot mark from space. So I will go to the board and you'll see how this reporting can be done. Then you take note that the aim that I'm going to put up, which I will not write again, is that the aim of this experiment is for experiment 1, testing solution A for starch using iodine solution. Then for experiment 2 is testing solution B for fats using Sudan 3 solution. And then the aim of experiment 3 is testing for glucose or simple sugar using the Benedict solution. And then experiment 4 is testing for the presence of proteins in solution A using the Melon's reagent. So I will go to the board now and you'll see how the report